We're going to look here at integrating a sine or a cosine function times an exponential. This is another problem where we have to use integration by parts twice, but it's kind of a special case. And the reason is, if you think about it, when you have an exponential like e to the x or e to the 2x, if you take the derivative of that and then you take the second derivative and continue on, you're really just getting, in this case, we get e to the 2x repeated over and over again, and there'd be a coefficient on the front that doubles every time. If you take the derivative of sine and you repeatedly take the derivative, it's going to change between sine and cosine, and the sign of the plus or minus is going to change. But neither one of these ever really gets any simpler when you take the derivative or when you integrate. So let's look at how to do this. First up, you want to choose one of them to be your u and one of them to be your dv. And it doesn't matter which one you pick for which. You can do it either way. The thing that is important is when we do integration by parts again later, we have to choose the same thing for our u and dv. So let's look at this. If we take the derivative of u, we get du is 2e to the 2x dx. And if we take the integral of dv, we get v equals, let's see, integral of sine is negative cosine. So we get negative cosine 5x. And since we integrated this and it's got that 5 on there, we have to divide by 5. So this is our stuff to use for substitution. So I'm going to rewrite this. Remember, it's uv minus integral v du. So when I rewrite this integral, it's going to give me, let's see, uv. I'm going to put the 1/5 out front. 1/5 e to the 2x cosine 5x minus integral v du. So integral of v du. And now let's combine the 1/5 and the 2 and bring those out front. So we've got negative 1/5 e to the 2x cosine 5x. And let's see, this becomes plus 2/5 integral of e to the 2x cosine 5x. I always like to put my I like to put my exponential first and then my trig function, but it really doesn't matter. Okay, so we've gone from this original integral to this one. And in this case, it hasn't gotten any simpler. We've still got an exponential times a trig function. So what we do is we do integration by parts again. And in this case, we're doing it on this integral over here. And what I have to do here for this to work is up here I'll let u equal e to the 2x. I got to do the same thing down here. U equals e to the 2x. And then dv is going to be cosine 5x dx. All right, so differential of this gives me du equals 2e to the 2x dx. And integrating this gives me, let's see, if you integrate cosine, you get positive sine, so this is going to be sine 5x. And again, we're integrating, so we're using the chain rule backwards, so we got to divide by 5. And so now we have to rewrite things using this. All right, so we've got our integral is equal to negative 1/5 e to the 2x cosine 5x plus 2/5, big bracket. Now I've got to do uv minus integral v du. Now, in the interest of space, I think I'm going to do this in one step. Well, so my uv is going to be 1/5 e to the 2x sine 5x minus integral v du. Let's see, when I put v du together, I get 2 times 1/5. I'm going to go ahead and bring that out front. So I get 2/5 integral, let me rewrite that so it's neater. 2/5 integral of e to the x sine 5x dx. All right. So now let's take this 2/5 and distribute it across this. So I get 2/25 e to the 2x sine 5x, and then I get minus 4/25 integral of e to the x sine 5x dx. All right, so we've done integration by parts twice, and if you look at this integral that we have down here now and compare it to the one we started with, let's see, shrink it down a little bit so they both fit on the screen. This integral and this integral are exactly the same, except for I miscopied here. These should be 2x's. But those two integrals are exactly the same. So it looks like we've gone in a circle, and I guess we have, but it works out. Because if you think about what this is, let's I'm going to let this equal I just for integral. So if we take that and we follow the chain of equalses down here, we get I equals this. And this thing right here is the same thing. So this is I. So what I've got here now is an equation that I can solve for I. So let's look at what this equation says. It says I equals minus 1/5 e to the 2x cosine 5x plus 2/25 e to the 2x sine 5x minus 4/25i. So what I'm going to do is on both sides of this, I'm going to add 4/25i. So what I've got over here is 29/25i. Just, adding these guys up. I get that equals, I'm going to skip a little space here, negative 1/5 e to the 2x cosine 5x plus 2/25 e to the 2x sine 5x. And I'm going to give myself a little more space there, because now we're almost done. We've got to multiply both sides by 25/29. And I could do brackets and multiply everything out like that, but instead I'm going to go ahead and distribute it. 25/29 times this plus this times 25/29. So we get that our integral that we were looking for is, let's see, I'm going to combine these fractions together. That's going to be negative 5/29 e to the 2x cosine 5x. And over here, the 25's cancel, and we're left with 2/29 e to the 2x sine 5x. And then don't forget, this is an integral, so we have to put a constant of integration on the end. And so that is our answer. It's a fair bit of work, but for any problem like this that involves e to the x, maybe with the constant on the front, times sine or cosine of the constant times x, this method will work.